Hello, we are going to do 7.2 notes today on inverse functions, continuing on with what we did yesterday. Everyone should look at page 3 of your notes. And just a little review from yesterday. Here's the unit circle for just the top half. Notice it's just from 0 degrees to 180 degrees or 0 to pi. Remember that that is where the principal values lie for cosine, its reciprocal secant, and also cotangent. So when you're doing inverse trig functions for cosine, secant, or cotangent, you always want to give answers between 0 and pi in radians or 0 and 180 for degrees. If you're trying to find inverse functions of sine, cosecant, or tangent, it's different and it's a little trickier. Remember that sine, the answer is going to be in the first or fourth quadrant. However, it's not first and fourth quadrant where the fourth quadrant is 270 to 360. It has to be one continuous thing, and it's from negative 90 degrees all the way to positive 90 degrees. Sorry about that. So negative 90 degrees to positive 90 degrees, or negative pi over 2 to pi over 2. So if I ask, where is the sign negative? You would first of all know it's in the fourth quadrant. And then if I more specifically said, where is the sign negative 1/2? You would not say 330 degrees, you would say negative 30 degrees. Okay, so now we're going to do some examples. Some of the examples will come from the unit circle and some will not. You still, however, have to follow the rules for where the inverse trig functions have to come from. Remember, whether it's with cosine, secant, and cotangent, that's the first and the second quadrant, or sine, tangent, and cosecant, that's the first and the fourth quadrant. Now I have this little note here. If the value is not from the unit circle, you must draw a picture. You might want to draw a picture anyway, so it's okay to draw a picture on everything, but on the problems that are not unit circle values, you have to draw a picture. Okay, so this very first problem has the sign of the inverse tangent of 1/2. So what we're trying to find, first of all, is where is the tangent 1/2, and then that place where the tangent is 1/2, what's the sine of that same angle? So first thing you need to do is figure out the information you can figure out about where the tangent is 1/2. Hopefully you realize there is no place on the unit circle where the tangent is 1/2. So you have to draw a picture for this one. Since there's no place on the unit circle where the tangent is 1/2, you need to draw a picture. Since the tangent is positive 1/2, we know it's in the first quadrant. Remember that tangent is y over x, so that's why I put the 1 here and the 2 here. So in order to figure out the sine, we need to figure out the radius of this angle. So use the Pythagorean theorem. We know 1 squared plus 2 squared is r squared, so r squared is 5. Therefore, r is the square root of 5. Now we can figure out the sine of this angle. So we never actually figure out what the angle is. You could using a calculator, but you don't have to. But we have a picture all about this angle with its characteristics. So now from this picture, I'm going to find the sine of this angle. And remember that sine, using x, y, and r, is y over r. So I know the sine is going to be 1 over square root 5, which simplifies to square root 5 over 5. Okay, let's go ahead to the next problem. And you always want to work from the inside parentheses out. Notice this is where the sign is negative 1/3. Now again, there is no place on the unit circle where the sign is negative 1/3. Now you need to be careful. If we're asking where the sign is negative, remember the inverse sign, the answer needs to either be in the first or fourth quadrant. Everything's positive in the first quadrant. So if we're asking where is the sign negative, we know that this angle is in the fourth quadrant. So you want to draw a right triangle in the fourth quadrant. Sine is y over r. Because it goes down, I know the negative goes with the 1, and r is always positive. Then you use the Pythagorean theorem to find the corresponding x value, so I can eventually find the cosine of this same angle. So x squared plus negative 1 squared equals 3 squared. X squareds are unknown. So x squared is going to end up being 8. And if x squared is 8, then I know that x is going to be the square root of 8, which ends up being 2 root 2. Because it's going to the right, I do know that x value should be positive. Remember, when you take the square root, it could be positive or negative. So now that we know x, y, and r, we can now figure out the cosine. So we know all the information about this angle, and so we know cosine is x over r. So then I just have to know, okay, the cosine is going to be 2 root 2 over 3, and that doesn't simplify it anymore, so that's the answer. Okay, moving on to example C. Notice in C, the inside parentheses says the angle whose cosine is negative 1/3. Again, that is not the unit circle, so we have to draw a picture. Because the cosine is negative, I need to draw my right triangle in the second quadrant. Remember, cosine, the inverse trig function for cosine, the answer ends up being in the first quadrant or the second quadrant between 0 and 180 degrees. Because it's negative, I know it's in the second quadrant. So cosine is x over r. So I know my x is negative 1 and my r is 3. I'm going to again use the Pythagorean theorem to find my corresponding value. This time it's y that's missing. So we end up getting that y squared is 8. So that means y is the square root of 8, which is 2 root 2. Because it's going up, I know that my y value is positive. So now I just need to find the tangent of that angle. Tangent is y over x. So I'm going to do 2 root 2 over negative 1, which simplifies to negative 2 root 2. Now part D, you can do this problem a little bit differently than the other ones. If you look on the in the inside, it says the inverse sine of negative root 2 over 2. The angle whose sine is negative root 2 over 2 is on the unit circle, so you don't have to draw a picture. Now, say you get in the mode of drawing the picture and doing them all like the other problems, it will still work on the unit circle ones. So the way I showed you to do problems A, B, and C, that will work on all of these types of problems. But it can be a little quicker if you understand the unit circle. So what you want to do in this one is work from the inside out. Because we're asking where's the sign negative, we know that angle is going to be in the fourth quadrant. And because it's in the fourth quadrant and it's negative root 2 over 2, I know that that angle is going to be negative pi over 4. I know the places where the sine and the cosine or root 2 over 2 are in the pi over 4 family. And remember, for sine, if it's negative, you actually have to go this direction because the answer is between negative pi over 2 and pi over 2. So the answer is negative pi over 4. So now what you want to do is just substitute this. You're going to take your inside parentheses, instead of having the tangent of the angle whose sine is negative root 2 over 2, you're going to say the tangent of negative pi over 4. So you're just going to substitute that value because you actually figured out where is the sine negative root 2 over 2. And now all you have to do is use the unit circle again and think, what's the tangent of negative pi over 4? Well, realize the tangent of negative pi over 4 is just going to be negative 1. Because remember, the coordinates at negative pi over 4 are both root 2 over 2. One's positive and one's negative. So this next problem, we get to use the unit circle again, and we don't have to draw a picture. I'm just drawing to show where is the cosine. First of all, it's negative root 2 over 2, so we're figuring out where it's negative. We know it's in the second quadrant. And if it's negative root 2 over 2, we know it's the pi over 4 family. So in the second quadrant, that's 3 pi over 4. So now all you have to do is substitute 3 pi over 4 into here. So now you're going to find the cotangent of 3 pi over 4. And then realize the coordinates there are going to give you a cotangent of negative 1. F, however, looks kind of like unit circle in disguise, but it's not. Realize in the unit circle, we have square root 3 over 2. We don't have square root 2 over 3. So this one, you do have to draw a picture. And we're asking, where is the cosine negative root 2 over 3? If it's negative, we know it's in the second quadrant because this is cosine. The x value is going to be negative root 2. The r is 3. Use Pythagorean theorem to find the corresponding y value. So we end up getting y squared ends up being 7. So y is the square root of 7. I'll give you time to write that down. I think that was a little fast. And then from there, you're going to find the cosecant of this same angle. So cosecant, remember, is the reciprocal of sine. Sine is y over r. So cosecant is going to be r over y. So the r value is 3, the y value is 7, square root 7. So then we just need to rationalize it, and your answer ends up being 3 square root 7 over 7. Okay, starting with example G, the problems get a little bit different. Notice in these problems, the inverse trig function is on the outside, where all the other problems we did so far, the inverse trig function was on the inside. So these ones, you definitely can just use your unit circle if it's unit circle right off the bat. So work from the inside out. You first of all want to think at pi over 3, what's the sign? And so the sign of pi over 3, we know is going to be root 3 over 2. So you just fill that in. And then you want to ask, where is the cosine root 3 over 2? And because the sine, it was pi over 3, the cosine is actually going to be pi over 6. You think about the picture, pi over 3 is here, pi over 6 is here. This is where the cosine is root 3 over 2. Now in part H, we have the same idea. This time it's asking, where is the sine, the same value as the cosine of 5 pi over 6. So where the cosine and the sine have the same answer, it's going to be two different angles. This one's 5 pi over 6. We need to figure out what angle does the sine have the same value where the cosine is 5 pi over 6. So 5 pi over 6, second quadrant, and we know that the cosine at 5 pi over 6 is negative root 3 over 2. So then we just want to fill that out, negative root 3 over 2, and we want to figure out with the sine of that same value, where is the sine equal to that? So where is the sine negative root 3 over 2? Realize if it's negative, we need to be thinking about the fourth quadrant, and that is the pi over 3 family, and since we're doing the fourth quadrant, it's going to be negative pi over 3. This next one has tangent and tangent. Sometimes these undo each other, and you just get pi over 6 back. Sometimes they do not. And you'll probably see a pattern eventually when you get it back and when you do not. But I'm going to go and do it the long way first. First of all, I'm going to figure out what's the tangent of pi over 6. So the tangent of pi over 6, I know the coordinates at pi over 6 are root 3 over 2 comma 1/2. Remember that tangent is y over x. So the tangent of pi over 6, I know it's 1/2 over root 3 over 2. And if you were to simplify that, you would get 1 over root 3, which is root 3 over 3. So then you want to figure out where is the tangent root 3 over 3. And that is pi over 6. The reason you got pi over 6 back on this one is because it's in the first quadrant. So a rule of thumb is if the original problem has an angle in the first quadrant, and you have the two same trig functions here, they do just undo each other and it gets pi over 6. If you understand that, you can just go straight to the answer. This next one though, 11 pi over 6, is not the first quadrant, so you do need to go through the steps. So 11 pi over 6, that's in the fourth quadrant. So you need to draw a picture, 11 pi over 6, and we know the sine of 11 pi over 6 is negative 1/2. So then we want to figure out where is the sine negative 1/2. Now this can be a little tricky because I know if we're trying to ask where's a sine negative, it needs to be in the fourth quadrant. Well, this already is in the fourth quadrant, so the answer is just 11 pi over 6, right? No, wrong. The reason is we know our sine, inverse trig functions of sine, the answer has to be between negative pi over 2 and pi over 2. So if we're in the fourth quadrant, it's not going to be 11 pi over 6. It's actually going to end up being negative pi over 6. And that ends up being your answer. So in examples K and L, we again have inverse trig functions of its same one. So again, sometimes they cancel each other out, sometimes they don't. If it's not in the first quadrant, it's definitely not going to cancel it out. So just be careful with that. So this one I'm going to just use some symmetry. I know that 7 pi over 6 is in the third quadrant. I know that the tangent is positive in the third quadrant. But if we're doing an inverse tangent and we're asking where is the tangent positive, it would need to be in the first quadrant. So the answer actually ends up being pi over 6. instead of just doing it that way, if that's confusing for you, you could do it the long way. You could figure out, okay, what's the tangent of 7 pi over 6? And I know the coordinates at 7 pi over 6 are negative root 3 over 2, negative 1/2, and tangent is y over x. So it's negative 1/2 over negative root 3 over 2, which simplifies to the inverse tangent of positive 1 over square root 3. If we rationalize it, it'd be square root 3 over 3. But for all intents and purposes, it helps just to figure out where is the tangent have this value. We know that the tangent is y over x. So where is the y value? We have a negative over negative. So where is the y value? Positive 1/2 over positive 1/2 over root 3 over 2, and that ends up being pi over 6. Because if we're asking where is the tangent equal to this value, it has to be in the first or fourth quadrant. Since it's positive, we know it has to be in the first quadrant. So example L is very similar. 5 pi over 3 is in the fourth quadrant, and we know that cosine is actually positive in the fourth quadrant. But if we're doing the inverse cosine and we're saying where is the cosine positive, it should actually end up being in the first quadrant. And you could do that logically, or you could just think, okay, the cosine of 5 pi over 3 is positive 1/2. Where is the cosine positive 1/2? If it's positive, it needs to be the first quadrant, and that ends up being pi over 3. So notice they're both pi over 3 families, but you just have to move the quadrant. So these last examples in your notes are going to be dealing with reciprocals and inverses. You have to be careful. Lots of times people get confused and they think that the -1 means reciprocal when it actually means inverse. So then when you put them together, sometimes people get even more confused. So remember, secant and cosine are reciprocals. So the secant of an angle is going to equal 1 over a cosine of that same angle. But if you're asking where is the secant equal to this value, that would be the same thing as saying where is the cosine equal to the reciprocal of that value. So if you're doing inverses, you actually have to do the reciprocal of what's of the argument of what you're taking the inverse trig function of, instead of taking the reciprocal of the whole thing. Now, even though cotangent and tangent are reciprocals, this formula right here doesn't always work, but it will help you get to your answer, and I'll be showing you that in the future. The reason is, remember that tangent's principal value answers have to be between negative pi over 2 and pi over 2 in the first and fourth quadrant, where cotangent's inverse values are supposed to be between 0 and pi in the first and second quadrant. So here in example M, we have the inverse cosecant of 2. That's saying, where is the cosecant equal to 2? But that could be a little harder to do. So what I like to do is change it first to its reciprocal. So the reciprocal of cosecant is sine. So instead of saying, where is the cosecant equal to 2, you can say, where is the sine equal to the reciprocal of 2? And the reciprocal of 2 is 1/2. So these are equivalent statements. Where is the cosecant equal to 2? And where is the sine equal to 1/2? Now that's unit circle. And where is the sine equal to 1/2? That's the first quadrant. And we know the answer is pi over 6. In this next one, we have where is the secant equal to negative 2 root 3 over 3. Now, that number can be a little tricky. So what I have here is I've went ahead and wrote the reciprocal of this negative 2 root 3 over 3. I just flipped it, and now I'm going to have to rationalize it by multiplying the top and bottom by square root 3. So we get negative 3 square root 3 over root 3 times root 3 is 3, so over 6, which simplifies to root 3 over 2. So it'd be best if you just memorize this, that the reciprocal of negative root 3 over negative root 3 over 2 is actually negative 2 root 3 over 3. But if you ever forget, just find its reciprocal and you'll see, oh, it's negative root 3 over 2. So then when we do this problem, we're going to rewrite it as cosine and say, where is the cosine negative root 3 over 2? So if you're saying, where is the secant equal to negative 2 root 3 over 3, equivalent statement would be saying, where is the cosine, the reciprocal of that, which is negative root 3 over 2. because it's where is the cosine negative, we know it's in the second quadrant, and that is going to be 5 pi over 6. So this next one is cotangent. Cotangent can be tricky. My advice to you on cotangent is don't change it to tangent unless there's no other way to do it. This one, we can do it without changing it to tangent. So the first thing you want to do is think, okay, let this negative root 3 over 3, what was it originally before it was rationalized? So I'm going to unrationalize it, and I know that is actually going to be negative 1 over root 3. And then I need to realize, oh, that negative 1 over root 3 came from coordinates of negative 1/2 and root 3 over 2. You might not be sure where the negative goes, and that's okay. But if we're asking where's the cotangent negative, that means we're in the second quadrant. And in the second quadrant, x is negative and y is positive. So if x is negative 1/2 and y is positive root 3 over 2, then I know that is part of the pi over 3 family, and it's in the second quadrant, so it's 2 pi over 3. So this next one is secant, and secant I would go ahead and write it as cosine. The reciprocal of root 2 is 1 over root 2, and then if you rationalize it, it ends up being root 2 over 2. So now you're just saying where's the cosine positive root 2 over 2? That's the first quadrant, it's pi over 4. This next one is where is the cosecant negative 1? Now the reciprocal of negative 1 is also negative 1. So I'm just going to rewrite it as where is the sine equal to negative 1? And the sine is equal to negative 1 in radians at negative pi over 2. You don't want to say 3 pi over 2. Remember, the answers have to be between negative pi over 2 and pi over 2 for sine. Cotangent, where is the cotangent equal to negative 1? Now remember, the tangent and the cotangent equal values of 1 and negative 1 for the pi over 4 family. Since it's cotangent and it's negative, we know it needs to be in the second quadrant. So that in the second quadrant with the pi over 4 family is 3 pi over 4. I know these notes have been long. We're getting close to the end. This last part, you use your calculator. So these ones are going to be values that are not unit circle. And we eventually have tests on chapter 7. You'll have parts that are calculator and not calculator. If it's not unit circle, you'll be allowed to use a calculator. And you want to round everything to 2 decimal places. Make sure you show work. Don't just write the answer. Our calculators do not have reciprocal functions, so you need to show what you're typing in the calculator before you write your answer. Okay, so in example S, it's saying find the angle whose secant is 3. First thing you want to do is rewrite it with this reciprocal and say, okay, where is the cosine 1/3? That is not unit circle. So that means we need to use our calculator. So go ahead and make sure you're in the right mode and make sure you're in radians. Your book loves radians. And then exactly what you wrote right here, the inverse cosine of 1/3, that's what you're going to type in your calculator. So you're going to go second cosine and then go 1/3. And then we're going to round it to 2 decimal places, so 1.23. Example T is the inverse cosecant of negative 4. So where is the cosecant equal to negative 4? First thing you want to do is change it to sine. So if you're asking where's the cosecant negative 4, it's the same thing as asking where is the sine, the reciprocal of negative 4, so negative 1/4. Again, that is not in the unit circle, so we punch it into our calculator. So you just go second sine, and then you have negative 1/4, and then round it to 2 decimal places, so the answer is negative 0.25. So these last 2 examples are cotangent, and cotangent you have to be super careful with. Normally, I would say try not to change cotangent to tangent. However, we're going to have to use our calculator, and there's no cotangent button on our calculator. So we do need to change this to tangent. So if it's asking, where is the cotangent 1/2? It could be the same as asking, where is the tangent, the reciprocal of 1/2, which is 2. Now, This one does work out because the same place where the cotangent is positive, the tangent is positive. It's all in the first quadrant. So if they end up being in the same quadrant, you don't even need to worry about it. It's going to be correct. So you just go second tangent and do where is the tangent to, and then round it to 2 decimal places. So 1.11. Okay, so now we're on the very last problem. This one's a little tricky because where the cotangent is negative is a different quadrant than where the tangent is negative. But there is symmetry, so we are going to use tangent to figure it out, and then from there we'll figure out exactly where is the cotangent equal to -2. So first thing you need to do is think, okay, where is the tangent, the reciprocal of the reciprocal of -2, which is -1/2. So I'm going to punch that into my calculator. So second tangent, -1/2. Now, this is going to be the sort of like the principal value that's going to help me get my answer, but it's not actually the answer. So we need to use symmetry. Negative angles are in the 4th quadrant, and -0.46. If that's kind of confusing to you, just think about different radians. So for instance, pi over 2 is 1.57. Half of that would be 0.78. So 0.46 would be right about here. Now, if that's where the tangent is -1/2, the cotangent would be equal to -2 and the symmetric angle in the 2nd quadrant. And they should have the same symmetry. Sorry, that's a really bad picture. And so that distance right there should be 0.46 away from pi. So what you're going to do is actually go pi minus 0.46. And then that is going to give you your answer. Now, if that goes way over your head, I know this video is getting long. I would be happy to show you that more when we get back. And I actually should have used our stored value. So let me try that one more time and I'll give you a little bit better answer. So I'm going to do inverse tangent of -1/2. And then I'm going to do pi. First I'm going to multiply that by -1. And then I'm going to do pi minus that answer. And so that ends up being 2.68, which works out because that would be the 2nd quadrant because we know pi is 3.14. Okay, so that's finally the end of the notes. All the homework is book problems. This is all on Canvas for you. All the book problems are on Canvas for you. So get started on your assignment and make sure you're checking your answers so you can ask me questions when I return. Have a good day and be good for the substitute.